Magandang araw! I hope everyone who is watching this video is safe, healthy, and happy. So this video, we will have a discussion on naming alkenes. I'd like to remind the viewers that you should have watched the video on naming alkenes because there are some concepts there which will be useful in our discussion. So, alkenes are unsaturated hydrocarbons that contain carbon-carbon double bond. Okay? The general formula for alkenes is CnH2n, while alkenes are also called olefins because they are considered to be oil formers. Now, we will use the IUPAC in naming alkenes. So, just like alkanes, we need to find the longest chain that contains, this time, the double bond. We number the carbon atoms in the chain, beginning at the end nearer the double bond. But this time, we shall use the suffix ene or in, instead of ane for alkane. So this time, we will use in. Now, for multiple double bonds, we can use suffixes like diene, triene, and so on. So the simplest alkene is one which contains two carbon atoms. So we have CH2, double bond CH2, and we call that ethene. Next, we have propene or prop-1-ene in some books, no? Ganito yung pagkakapresent ng pangalan. They mean the same thing. And just propene is acceptable for one propene. Okay, where one propene is an alkene where the double bond is between carbons 1 and 2. Then we have one butene, so 1, 2, 3, 4, and where the double bond is at carbon number 1. We also have 2-butene, where the double bond is between carbons 2 and 3, also called bu-2-ene. And then we have double bond. So we have 1, 2, 3. So the double bond occurs at carbons 1 and 3. So this is called 1,3-butadiene. So notice the use of hypen and dash to separate numbers and letters. So, it's not butadiene, it is butadiene or buta-1,3-diene. Then, we have 1-pentene or pent-1-ene. Again, for one, dropping 1 is acceptable. Now, we have here another multiple bonded alkene. So, we have 1,2,4 penta triene or penta 1,2,4 triene. Notice the number of hydrogen attached to the carbon involved in the double bond. Okay? Also notice, by the way, that this is the line bond structure of propene. Notice the carbon double bond, carbon single bond, and the carbon-hydrogen single bond. But this is tedious to do, so we shall use either the condensed structural formula or the skeleton formula. Now, alkenyls. What are alkenyls? So, alkenyls are analogous to alkyl. So, yung alkane, pag tinanggalan mo ng hydrogen, ang tawag natin ay alkyl dun sa matitirang hydrocarbon group. Dito naman, yung alkene, pag tinanggalan mo ng hydrogen, ang tawag natin ay alkenyl. Okay? So, we use the suffix -enyl. No? And the numbering of carbon starts with the carbon atom attached to the main chain. No? So, hindi papakialaman yung double bond sa numbering. Kung hindi, yung carbon na naka-attach sa parent chain will always have carbon number 1, no? It will always be assigned as carbon number 1. So, if we have an alkenyl like this one, so this is 1-butenyl because carbon 1, which is attached to the parent chain, has a double bond. Okay? So, this is 1-butenyl, 2-butenyl, and 3-butenyl. You might be confused because why is this 3-butenyl when the double bond is at carbon number 1? No. The numbering of carbon is always based on the parent chain. Okay? The carbon bonded to the parent chain is always assigned as carbon number 1. So, for example, we have here a chloride. So, we have 3-butynyl chloride. Now, a few alkenyl groups have trivial names, so they have common names. So, for example, ethynyl from ethene, no, we abstracted one hydrogen and we have now ethynyl. So, its common name is vinyl. So, this is a precursor for PVC or polyvinyl chloride, which is a thermoplastic. Then we have 2-propenyl because this is carbon 1, 2. The double bond is at carbon number 2. So, we have 2-propenyl or allyl. So, remember, vinyl is composed of 2 carbon. Allyl is composed of 3 carbon. So, allicin is the active ingredient in garlic. No, yun yung naaamoy natin pag brinake natin yung garlic. Allicin is actually diallyl thiosulfinate. Okay? And then we also have commonly called isopropenyl or IUPAC name 1-methylethidyl. So, the alkenyl has a substituent which is methyl in this case. Okay? So, we have this ethynyl and then this methyl is considered to be a substituent for this ethynyl. So, this is 1-methylethinyl. Okay? Now, note that the hydrogen atoms bonded directly to the unsaturated carbon-carbon atoms involved in the double bond are called vinyl hydrogen. So, we have 1, 2, 3 vinyl hydrogens in ethynyl. We have 1, 2, 3, 4 in propenyl, and then 1, 2 in isopropenyl. So, we call that vinyl hydrogens, or more accurately called alkenic hydrogens. Now, if the double bond is equidistant from the two ends, we begin numbering at the end nearer the first branch point. If there is no substituent, no matter where you start numbering, that's okay. But if there is a substituent, you consider the substituent, okay? So, this ensures that the double bond carbons receive the lowest possible number if we start numbering nearer the first branch point. So, this is 1, 2, 3, 4, 5, 6. So, we have 3-hexene, but there is substituent, a metal substituent at carbon number 2. So, this is 2-methyl-3-hexene or 2-methyl-hex-3-ene. Now, if there are more than one substituent, we should be able to identify and number the substituents according to their position in the chain while listing them alphabetically. Okay? So, notice that the black ink is the longest chain. So, this is the pairing chain. So, we have 1, 2, 3, 4, 5, 6, 7. And there are 3 double bonds. So, this is a heptatriene. So, we start numbering from this carbon. This is carbon 1, 2, 3. And there are substituents in carbon number 4, carbon number 3, and carbon number 5. So, we identify the substituents as chloro and then methyl. So, this is called 4-chloro, 3,5-dimethyl, 1,2,4-heptatriene. I hope you still recognize the use of dashes and commas in naming. Now, how about cis-trans transfiguration? Okay, so there are geometric isomers in alkene, so we have to consider that. So, if there are only 2 substituents, again, there are only 2 substituents, we can use the cis-trans configuration or cis-trans notation. So, notice that hydrogen, both these hydrogen are on the same side of the plane. So, we use cis meaning same side. So, we affix the word cis dash 2 dash pentene. So, this is pentene. So, 1, 2, 3, 4, 5. Okay. Now, if the hydrogen are located opposite each other, we have trans 2 pentene. Okay. So, this is how we express the previous molecules using skeleton formula. So, this is trans and this is cis-2 pentene. For you to be able to see that clearly, so these are the hydrogens, obviously, of opposite side of the plane. And these are the 2 hydrogens on the same side of the plane. So, cis-2 pentene and trans-2 pentene. Alright, now, if there are 3 or more substituents, the cis-trans notation will no longer be applicable, and therefore, we can use now the EZ notation. E for androgen, Z for zooxamine. So, This time, we have to consider the priority of the substituents on the carbon, on the vinyl carbon. So, we have to compare bromine and ethyl group, okay? So, the higher the atomic number, the higher is the priority. Obviously, between bromine and carbon, bromine has a higher atomic number and therefore bromine is of a higher priority. Methyl and hydrogen, again, carbon is has a higher atomic number and therefore of a higher priority. So the two substituents which are of higher priority are located opposite one another, and therefore this is called E, but this time we have to enclose E in parentheses. So this is E 3-bromo-2-pentene, meaning E of opposite side. This time the substituents which are of higher priority are on the same side of the plane, and therefore we have Z 3-bromo-2-pentene. Z meaning same side. So medyo madaling tandaan, cis at saka Z. Tapos ET, opposite. Okay, we also have this. So we do the same. We compare. Chlorine is of a higher priority than hydrogen. Ethyl is of a higher priority than methyl. So the two substituents which are of higher priority are on the same side. So we have Z1-chloro-2-methyl-butene. So I hope you recognize now you have 4 carbon as the pairing chain. 1, 2, 3, 4. And chloro is attached to carbon number 1. And then methyl is attached to carbon number 2. Again, so we have Z1-chloro-2-methyl-butene. If they are opposite, we have E1-chloro-2-methyl-but-1-ene. So, what if we have something like this, no? So, there are two double bonds, okay? So, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So, we have a nonene, but there are two double bonds, so we have a nona-diene. So, identifying the substituent, we have 3-chloro-6-methyl. 2,5-nona-diene, but we have to consider the easy notation. So, let us try to find out. Okay, this is carbon number 3, and this is carbon number 2 rather. Carbon number 2 and carbon number 3. So, we show it here. So, this is the substituent Cl. So, this is Cl, and this whole thing, this alkenyl group is this whole thing. Okay? So, you have hydrogen there. So, this is that hydrogen. And you have methyl. And this is that methyl. Notice that methyl and chloro are of a higher priority. And they are on the same side. Therefore, C2 double bond is 2Z. So, 2Z. What about this double bond? Okay? So, we have C5 and C6. So, this whole thing is this one, and then we have hydrogen down there. Then this is CH3, we have CH3, and this whole thing 1, 2, 3 is the propyl substituent. This, the alkenyl group and the propyl are of a higher priority, and they are opposite, so we have nitrogen. So we have 5E. And therefore, the name of this compound is 2Z 5E 3-chloro-6-methyl 2,5-nona-diene. Carbon number 2, the double bond is same side. Carbon number 5, opposite, no, yung substituent. So we have 2Z 5E 3-chloro-6-methyl 2,5-nona-diene. What about cycloalkane? So we just affix the word cyclo. We use the system for the open chain alkenes. But numbering always starts at one of the carbons of the double bond. Okay? So this is carbon number 1, 2, 3. Okay? Either this is carbon 1, 2, or this is 1, 2. So, to keep the index numbers as small as possible, we name this as 1, 2, 3. So, 1, 3 dimethyl cyclohexene and not 1, 5. No? So, this is 1, 2, 3. So, 1, 3 dimethyl cyclohexene. And then, when an alkene is double bonded to a single carbon, so the suffix is ylidene. So, we have ethylidene cyclopropane and methylidene cyclopentane. So that's it. Thank you. I hope you have a clear grasp of naming alkenes. Stay safe and stay healthy, class. See you.